Morning. Right, this is a really quick video about the stuff that we're going to be doing this week. We're moving on, as you'll have seen from Mr. McConnell's messages, that all of the assignments that we have done up until now, we have now shelved those, and everything that we got caught up on last week, we are now done. So we're moving on to the next section of this unit, which is probability. Probability, definitely probability. And we're going to start with something just nice and simple. I want you to have a look at these statements, and I want you just to consider if they are true or false. So, for example, you are equally likely to get a heads or tails when flipping a fair coin. Okay. Now, I'm just going to help you with this one because it is. It's completely. It's a 50-50 chance. You've got a 50% chance of it happening, or a 0.5 probability of it happening. Half the time you're going to get heads. Half the time you're going to get tails. That's the nature of a coin flip. Okay. So for that one there, I would say definitely it's true. But what about the others? You are more likely to get an even number when rolling a fair die. Okay, so the key words here are more likely. Okay, an even number. So more likely means a probability of more than 0.5 or more than 50% chance of something happening. So it can't be 50%, it's got to be more than 50%. So have a think about that one. The other one, the probability of picking a red card is 2/3. Now let's have a look at those cards there. There are 1, 2, 3, 4 red cards and 2 black cards. The probability, look at the next one, the spinner. The probability of landing on a 1 on the spinner is 1/4 or 0.25 or 25%, whichever you want to use it is absolutely fine. Often we'll use fractions. Sometimes we'll use decimals. Actually, we very rarely use percentages for discussing probability. So there you go. So the probability of a 1, hang on, there is no 1 on there. So how could it's interesting. The probability of not picking a black card. The probability of not picking a black card is 4 out of 6. Okay, 4 on 6. And the probability of choosing an A from the word mathematics is 2 out of 10. Okay, so how do we work out the probability of things? If you guys will remember, you'll have a probability will work in that you have the total number of possible outcomes. Okay. The total number of different things that can possibly happen. That's going to be our denominator. We'll see some examples in a minute. And our numerator will be the number of ways that we want something to happen. So let's have a look at the probability of picking a red card is 2/3. This one right here. And it says, well, let's look at the total number of things that could possibly happen. There are 6 cards, so that means if I choose one card at random, that means there's going to be 6 different cards I can choose. So as a fraction, my denominator will be 6. Now, how many red cards are there? Because that's what it's saying. It says the probability of picking a red card. Well, there's 4 red cards. So there's 4 different ways of choosing that red card. So my fraction, I know, is going to be 4/6. 4 is my numerator, and 6 is my denominator. Now, for choosing an even number, well, if you roll a fair die, there's 6 different ways you can roll it. 1, 2, 3, 4, 5, 6. And that also means that it's going to be 3 even numbers and 3 odd numbers. Now, are you more likely to get an even number? No, it's a 50-50 chance. You're still going to have a 0.5 probability, or a 1 out of 2, or 3 out of 6. Okay, we might come back to these a little bit later. So this idea of probability trees stems from just a really easy and visual way of working out probability. This right here is an example of a probability tree. Now, let's say, for example, this was there are 10 different possible things you can choose, and there's 10 different balls that you can choose, for example, and 3 of them are red and 7 of them are blue. So I know the probability of choosing a red ball will be 3 out of 10 because there's 3 red balls out of 10 balls. And the probability of choosing a blue one will be 7 out of 10. Now, if you put the ball back in, there's still 10 balls, and then you can have a second choice. And you can see that the second choice is independent from the first choice. It doesn't matter because we put the ball back in. And if you choose blue first, and then you choose a red, that's okay. We can see that's still 3 out of 10, and that's 7 out of 10 as well. Okay. Now, let's just have a real simple example. Rebecca has 9 colored beads in a bag. 4 of the beads are black, and the rest are green. Okay, so we don't know how many. We don't know how many are green yet. We can work it out pretty easily. She removes a bead at random and notes the color and then puts it back in. All of these things are super important. And then she chooses a second bead. So we're going to draw a probability diagram. Our first choice, the only 2 possibilities are black and green. Now, what's going to be the probability of getting a black? Have a think. 4 black beads, the rest are green. She's got 9 beads in her bag. So how many different ways are there of getting a black bead? Well, there's 4. So our numerator will be 4, and because there are 9 beads in a bag, that means the denominator is going to be 9. So what about the green ones? Now, you can either say, well, let's think about this. If there are 4 black beads and there are 9 beads altogether, that means there must be 5 green beads. So I know my second probability is going to be 5 out of 9. The other thing that I can do is I can look at these 2 numbers, these 2 fractions, and I can add them together. If I add these together, I must get 1. So if I add these together, I get 4 over 9 plus 5 over 9, that equals 9 over 9, and that's the same as 1. So that's a good way of just checking if your answer is correct. Right, so this is the first choice. Now she puts the bead back into the bag, and then we have our second choice. So if she chooses the black bead first, and then the second choice, because she's put the bead back in, the probabilities are still exactly the same. Okay, and similarly, she could choose a green bead first, and then have a black bead or a green bead as well. So the probabilities down there are the same as well. Now just have a quick look at these 4 numbers right here. They do not add up to 1. It's only from each kind of branch of the tree that they add up to 1. So we're going from this point here, those 2 will add up to 1. From this point here, those 2 will add up to 1. This point here, those 2 will add up to 1. Now, we need to calculate the probability that Rebecca chooses 2 green beads, okay, and a black bead followed by a green bead. Now, let's have a look at our tree. I can see here that there is only one way that she can possibly get 2 green beads. First, she has to choose a green bead, and then she has to choose another green bead. So, when we're doing probability, there's a quick and easy way of organizing our sum, our probability, and this is something that you just have to really remember. If it's and, we have to times the 2 probabilities together. So here what we've got, I've got a black bead followed by a black bead. So probability of a black and a black equals 4 over 9, that probability there, times 4 over 9, that probability there. And that, you can do it on your calculator, and it equals 16 over 81. Well, what about black and green? Well, it's that probability, 4 over 9 for the black, times 5 over 9, which is that probability right there, which is 20 over 81. The probability of a green and then a black is 5 over 9 times 4 over 9, that times that. And probability of a green and then a green is 5 over 9 times 5 over 9, which equals 25 over 81. Now, another good way, just checking your answers, those blue numbers there, they should all equal, if you add them together, they should equal 1, which I think these do. 16 plus 20 is 36, plus 20 is 56, plus 25 is 81, 81 out of 81. Why does it add up to 1? Because 1 means 100%. There are only 4 different things that can possibly happen when you're taking out 2 beads. One is that you get a black and a black. 2 is you get a black and a green, then you get a green and a black, or you get a green and a green. So all of them, the probability of one of those things happening must be 100%. So that's why they add together to give 1. Okay. Now the question is, 2 green beads. What's the probability of 2 green beads? Well, I can see that down here, so that's going to be 25 out of 81. I've left it as a fraction because as a decimal, it's going to be something just not very nice. So we leave it as a fraction. Oh, my hair. Just seeing it in the mirror, in the video. And then a black bead followed by a green bead. Well, that's this root right here. Black followed by green. So that's going to be 20 out of 81. Nice and straightforward. That's our first answer, and that's our second answer. This is another example right here. Peter has 10 colored cubes in a bag. 3 of the cubes are red and 7 are blue. He removes a cube at random. Now this is different, shall we just say. This one here, it works on the important information here is that it does not replace, he does not replace the ball back into the bag. Oh, hello, Jasmine. My daughter's just come in. Hello. I don't know where JJ is. Do you know where JJ is? Oh, I'm making a video right now. You go and find Mummy. Yeah? You go and find JJ. Ask Mummy where JJ is, okay? Bye. Sorry about that. So we've got a hello. I don't know where JJ is. Maybe she's on the balcony. Go and have a look. She's not on the balcony? Is she in her bedroom? Go and have a look in her bedroom. First choice. So the first one's nice and straightforward because we've got 10 colored bags, so our denominator is going to be 10, and 3 of the cubes are red and 7 are blue. So the first 2 ones should be nice and straightforward, 3 over 10 and 7 over 10. But then what happens next? He does not replace the bead. Sorry, he does not replace the cube. And so the second choice, things will start to change, because how many reds? Let's look at the second choice after we've taken 1 red. Let's look at the second choice. How many reds are there now in the bag? Well, he has already taken 1 out, so the number of reds is going to go down. And how many cubes are there in the bag now? There's only 9 because he's taken 1 out. So the probability of getting a red a second time is going to be 2 out of 9 because there's only 2 reds left and there's still only 9 cubes in the bag. Well, what about blues? Well, the first choice doesn't affect the number of blues. So we're still going to have 7 blues in there, but we're only going to have 9 cubes. So we get 7 over 9. Well, what about if the first choice was a blue one? Let's have a look. Well, is the number of reds affected? No. So we still have 3 reds, but the number of cubes in the bag has gone down by 1 because we've already taken 1 out. So the probability of a red now is going to be 3 out of 9. And blues, well, there's one fewer blue cubes. So the number of my numerator is going to go down, and my denominator is also going to go down by 1. So I should get 6 out of 9. Yeah. Oh, and look at that. They add up to 1 again. 3 out of 9 plus 6 over 9 is 9 over 9. And 2 over 9 plus 7 over 9 is 9 over 9, which is 1. Okay? So we've worked out our probability tree with a first choice and a second choice when they do not replace the cube. And that's the very, very important part. So then we're asked, calculate the probability that Peter chooses 2 red cubes. Well, that's this one and this one. So it's going to be 3 over 10 times 2 over 9, which is 6 over 90. Okay. What's the probability? Well, let's go through them all. Probability of a red, then a blue. Well, it's going to be 3 on 10 times 7 on 9, which is 21 over 90. What's the probability of a blue, then a red? Well, it's going to be 7 on 10 times 3 on 9, 21 on 90. And what's the probability of a blue and a blue? 7 on 10 times 6 on 9, which is 42 over 90. Again, leaving them as fractions is a very, very wise decision here. Don't convert them, don't change them to decimals. Okay, so the probability of getting a red, then a red again is pretty low, 6 out of 90. So that's how many times you would expect to get it if you actually did the experiment. So if you did the experiment 90 times, you would expect, you could predict that 6 of those 90 times you would get a red, then a red. And a blue cube followed by a red cube is that one right there, and that's 21 out of 90. And this kind of makes sense because red and blue, blue and red is a higher probability, but the red is still pulling it down. And then the probability of a blue, then another blue, is a lot higher because there are more blues in the bag. So it makes sense that also the probability is higher as well. So this one here goes all the way up to 42 out of 90. Lovely stuff. Right. I'll leave it there for the time being. We'll move on to the next section, maybe, next time. All right. Bye.